surprisingly. And finally, we have our juror, Mark.
Morning, I'm here too.
Yes, good morning, Mark, and thank you so much for joining us at the last moment. We really appreciate your help. I need to explain that the problem of jurors not showing up is a massive problem for the IYPT, IYNT, and we are somehow trying to cope with this problem. In the IYPT, the physicist tournament, jurors are scheduled in advance, like 2 days before the fight. Then everyone believes that the schedule is final and all jurors will show up. But then obviously like 3 or 4 or 5 people do not show up. Then we have a problem because the schedule is fixed. And then we wait. And in some cases we had to wait for like 40 minutes, like last year in Warsaw, and one of the chairs did not show up. In the IYNT, we have a slightly different procedure. We build the schedules for the jurors who are present. And then this schedule is valid and correct and reflects the actual situation. But as we see today, some jurors decide that everything will be fine without them. They do not come as well. And then we are becoming short on jurors and we need to urgently look for replacements. So Mark, thank you very much once again. We really appreciate your immediate help. And I hope we will have enough jurors in all groups today. Thank you so much. Okay, let's check if Alexandros is around. Perhaps he went to another group. In case he discovers that he went to a wrong group and discovers that in 40 minutes from now, the between voices of what I say, between sounds of my voice, I hope that my voice is more or less clear. Is that the case? Croatia, Team Romania, Team Russia? Okay, then let's start with captain's contest. What we will do is that we will have 5 questions as yesterday, and we will collect the answers in direct messages to the chair. So I ask everyone, all 3 team captains, to make sure that you can see me and the list of people here, that you can send direct messages to me. Please make sure you can do it. In case you hesitate, you can send me a test message. There is a list of 5 mammals. Indicate only one, which is egg-laying. Here is the list: Arctic fox, Balochistan pygmy jerboa, domestic cat, platypus, and western gorilla.
Lame.
Can you repeat, please, first 2?
Okay, I will repeat quickly. Arctic fox, Balochistan pygmy jerboa, domestic cat, platypus, western gorilla, the only one which is not egg-laying. We're out of time and we have received the question. There is a list of 4 numbers. Indicate the only one which is a prime number: 96, 97, 98, and 99.
Can you please repeat the numbers, please?
96, 97, 98, and 99.
96, 98, 97, and 99.
Okay, we're out of time, and let's make voice check again. I ask all team captains to please confirm that you can hear me. Team Romania?
Yes.
Okay, Team Russia?
We can hear you, but not first word you saying, like.
Okay, and Team Croatia?
I can hear you completely.
Okay, good. Then I will try to speak slower I will speak as slowly as I can, but I cannot repeat the same question 10 times. Okay. Question number 3. Sun's magnetic field goes through a cycle and ratio of the solar system.
I can't hear you at all now. We can't hear
We
you now.
didn't hear anything as well.
Okay, I repeat the question. The magnetic field of the sun goes through a cycle and periodically flips. What is the duration of the solar cycle? Okay, next question. Arrange is 3 metals in the order of increasing density. The order of increasing density. Metals are iron, lead, and osmium. Iron, lead, and osmium.
Da. Evo što sam htjela reći. Znači, moja mama u Rijeci ima koronu. I moj tata, mislim ima je već. Moj tata koji živi s njom je svejedno došao na
Okay,
hospital.
can I please ask to mute one of the jurors?
Mislim, držao se dalje.
Okay, I hope she will mute herself. Question number 5. Arrange these 3 stars in the order of increasing visible magnitude. Increasing visible magnitude. Aldebaran, Sirius, and Sun. Aldebaran, Sirius, and Sun. Okay, thank you so much. I ask all team captains to please finish editing your answers. Okay, thank you. Let me just check that everyone is done. Please stop editing your answers and we proceed to checking the answers. Okay, starting with Team Romania. Okay. Okay, let's look at the answers in more detail and let's discuss them. Answers from Team Romania. Platypus, that's a correct answer. You have 1 point here. 27 is a prime number. That's correct. You have 1 point here as well. 11 years. Yes. Iron, lead, osmium. Yes. And finally, Sirius, Sun, and Aldebaran. That's a wrong answer because visible magnitude is increasing in the opposite order respective to the brightness. So Sun is the brightest star in the sky, but it has minimum visible magnitude out of these 3 stars. Your answer is Sirius, Sun, Aldebaran. You have Sun in the middle. So you have 4 points, Romania, so far. Congratulations on your 4 points. Now let's look at the answers from Team Russia, Uranium 239. Second one, second mammal. It was Baluchistan pygmy jerboa. No, that's a wrong answer. That's a very small rodent. Balochistan pygmy jerboa. It's tiny. It's just several centimeters in size. 97, yes. No answer in the third question. Lead, uranium, osmium. Uranium was not on the list, so you have 0 points here. And then Sun, Aldebaran, and Sirius. You have 0 points here as well. That was a good start. That Sun is the first in the list. And you have Sirius and Aldebaran in the wrong order. Sirius is the second brightest star in the sky, and it is second after Sun. So you have 1 point so far. Congratulations. Next, finally, I have answers from Croatia, and then I have also a message from one of the jurors. Still missing our chair in Group B. Okay. We'll be back to you. Group B has a problem with their chair. I'm really sorry for that. So we will complete the captain's contest, and then I will go there to solve the issue. The majority of chairs disappeared today as well. One of the chairs is in Belgium, and his internet is disconnected all the time. Okay, let's look at the answers from Team Croatia. Platypus, 1 point here. 97, yes. 11 years, yes. Iron, then lead, and osmium, yes. And Sun, Sirius, Aldebaran, yes. You have 5 points, Team Croatia. So with that result, I would like to congratulate Marita, team captain from Croatia, for winning captain's contest in our Group C. Congratulations. There is no need to ask the additional 6th question. We have our winner. And now I ask Marita to please decide on the order of performances.
Okay, just a second. I will now write it.
Okay.
Do I put it in the text or?
Yes, you can put it in the text channel.
Okay.
I'm sorry, can you please tell us what was the correct answer for the 5th question, the one with the stars? We didn't catch it.
Yes, I think I already explained it briefly, but let me do it once again. The answer is Sun, next Sirius, next Aldebaran. Sun is the brightest star in the sky, I think you agree. Therefore, it has minimum visible magnitude. And Aldebaran is...
I'm sorry, but we just searched and has minus 146, and Aldebaran has minus 2.1, and we believe that Sirius is brighter than Aldebaran.
Exactly. Therefore, you are completely right, and therefore, Sirius is brighter, and therefore it has less visible magnitude than Aldebaran. You can open the Wikipedia page for visible or apparent magnitude, and you can check.
Okay, so the order is Sun, Sirius, and then Aldebaran.
Yes.
Thank you.
Okay. So we see the decision from Marita. Thank you. The first report is Russia. The first opponent is Romania, and the third report is Croatia. Thank you so much. And now, unfortunately, I need to ask you to wait 4 minutes because I'm going to solve the Okay, Group C, I'm back to you. We were nearly we're nearly replacing the chair for Group B because he was absent. But he's back now, and basically had a medical situation, and he had so he's in self-isolation now, and he had a medical doctor coming and doing some procedures with him, and somehow the medical doctor came at the wrong time. That was the reason why they could not start as planned, but now they can start. Okay, good. In case everyone is ready, I would like to check with all teams once again. I have clock that I can display to you together with just with my face using the camera, or otherwise we can share a screen and we can have a clock yeah, just as a stream in our channel. What do you prefer? And in any scenario, I will be announcing the time at all times.
Live stream.
So you prefer to have stream, right?
Yes.
Okay, Florian, can you please volunteer to help? Then we have two backup clocks, your clock and my clock. Is this okay for you?
Yes.
Okay, and then Florian, would you please also announce the time? So saying time started, time finished. Can you do it?
Sure.
Okay, thank you. Let me just take my protocol, and there is no further preparation time for the first reporter for Team Russia. We ask you to please open your slides and start the presentation as soon as you can.
Time has started.
Well, don't start at the time for the report. Perhaps they need some 20 more seconds.
No, the preparation time, I mean.
Okay.
Do you see my presentation?
Can the opponent confirm, please? Can
1 second, we don't see it yet. It is loading.
It is loading for us too.
Okay, it loaded now. I think we see our screen, but it's not on the presentation. I guess he stopped it.
We have some technical problems. Can you wait for some minutes?
Sure, your preparation time is running. Okay, reporters, please be ready to start.
Do you see my presentation now?
Yes, Team Romania can see it now.
Okay, please start the report.
Hello, I'm Saratider Kirill from Team Uranium 239 and I present project number 11, hydrogen release. There you can see the problem of this project. There I needed to investigate how the reaction rate depends on the concentration of each salt and other relevant conditions. And also I needed to investigate what salts react with aluminum to release hydrogen.
Excuse me, our whole team doesn't see the presentation yet. So none of us can see it.
It's Milan here. I also cannot see it yet.
Okay, let's stop the time for a short pause. Team Uranium, please close the presentation, open it again. But once again, we cannot extend this forever, so we need to be efficient. Please drop your slides into the text channel, Team Uranium. Please continue talking. Yes.
I can see it now.
Yes, please continue.
Okay. I have selected a plan for working on the project. The first step is to create an experimental installation for measuring the volume of released hydrogen. The second step is to understand which reactions are in this process. The third step is to find the rate of releasing hydrogen and to determine rate dependencies on some parameters. The fourth step is to find salts reaction similarly with aluminum. For experiment, I make this installation. There are hydrogen collecting tank, thermometer, magnetic stirrer, and scales. Hydrogen collecting tank is a glass filled with water. There also are thermometers that needed to detect temperature of the solution, and there are scales to measure the mass of the water. There you can see that, look on the scheme, there we can see that H is difference between water height. Then write pressure equation in glass number 5. So we can see that the value of delta P is ignorably small. There you can see reactions. There are 3 processes. The first process is react between sodium chloride and copper sulfate, and also 2 parallel reactions between aluminum and water and between aluminum and copper sulfate. There you can see I used these formulas to measure the amount of water. The first formula was changing the volume. I measured using the mass of the water and its density. The second line is the Clapeyron law. I find the amount of released hydrogen, and using last lines, I measured the amount of water. If the conditions are constant, the reaction rate is constant. Hence, this formula is true. Also, I used in my project the linearization of Van Gogh law. It is Van Gogh law, and it is its linearized form. I assume that as the concentration of copper sulfate in the solution increases, the reaction rate will increase. As the area of the aluminum plate increases, the reaction rate will increase. As the concentration of sodium chloride in the solution increases, the reaction rate will change. As the temperature of the solution increases, the reaction rate will increase. Why don't we consider flatter? Let's plot the dependence of the amount of water consumed on time and approximate more slope of the line is the reaction rate. Why don't we consider the flatter part of the graph? The first point, it is because in one particular reaction there can be only one speed value, and therefore when the speed changes, the reaction system changes. Unfortunately, it isn't possible for me to determine what reactions occur in the solution, because I haven't enough information about mechanism of the reaction. Second point will be some later. For the first experiment, I changed concentration of copper sulfate solution. Then let's plot the dependence amount of photon time and then determine slopes of each line. After I plot the dependence rate on concentration. The second point why we don't consider the flatter part of the graph is that you can see the rate of this part of graph is constant for each concentration of copper sulfate. There you can see these lines. For the second experiment, I changed the sign of the plate. Let's plot the dependence amount of photon time and then determine slopes of each line. After I plot the dependence rate on concentration. There you can see that this line. For the third experiment, I changed solution temperature. Let's plot the dependence amount of photon time and then determine slopes of each line. After I plot the dependence rate on temperature. There you can see determination of the temperature coefficient using Van Gogh law. Let's plot for the fourth experiment, I changed concentration of sodium chloride solution. Let's plot the dependence amount of photon time and then determine slopes of each line. After plot the dependence rate on, so you can see that V equals constant. For the first experiment, I find two salts similarly react with aluminum. The first salt is ferric chloride, and there you can see video how it reacts with water with aluminum to release hydrogen. There you can see reactions with this salt. The first reaction is reaction between aluminum and ferric chloride, and the second reaction is reaction between aluminum and water. Second salt was the sodium hydrosulfate, and there you can see two reactions. Reaction between sodium hydrosulfate with aluminum, and the second reaction is reaction between aluminum and water. There you can see the video of this process. My conclusions. We investigated that when studied parameters exceed sodium chloride concentration, increasing the reaction rate increases. Also, we have found linear dependence of reaction rate or logarithm of rate on concentration of salts, aluminum plate area, and delta temperature. Thank you for your attention.
Okay, thank you very much for your report. We now move on to clarifying questions from the opponent, please. Questions from the opponent, please.
Okay, can you hear me?
Yes.
Yes.
Okay, well, I wanted to ask you first. I've seen that in one of your reactions, aluminium reacted with copper and chlorine. Are you sure that copper is reactive enough to make these compounds?
You asked about these reactions?
Yes. Sodium and copper and chlorine in the first reaction. Can they react like that?
Yes, of course, because the solution changed its color from blue to green.
All right, now another question. Why do you think that temperature is an important factor, and also how does the temperature of the reaction work?
This law shows us how the rate of the reaction depends on temperature.
Well, okay, you say that it depends on temperature, but still, is an exothermal or endothermal reaction, or it's just a normal reaction with no heat consumption or production?
It is exothermal reaction.
Okay.
But I control the temperature of the solution on all time of the reaction.
So you say that the environmental temperature is not an important factor?
No, because the reaction rate depends on only temperature of the solution, and I control the temperature on the solution constant.
How did you control the temperature, thinking that it was producing its own heat?
I added some cold water in outside container when I needed to cool down, and I added some hot water to when I needed to make water in the solution hotter.
Okay, but why would you want to make the water hotter, thinking that it was producing heat increasingly?
Because the solution was cold because the temperature or the environmental temperature is lower than the temperature of the solution, and I needed to add some hot water to this container to make the big temperature for 35, 40, 45 in solution.
Time.
Okay, I understood. It's okay. Thank you.
Okay, preparation time is running now. Thank you. Okay, it's the time to start. Please start.
Anyone hear me?
Yes.
Yes.
All right. Can you see my PowerPoint?
Yes.
Okay. So, hello everyone. My name is Morarash, and today I'm representing Romania for problem 11, hydrogen. So, I think that you've seen the task of the problem, and now let's move on to the opinion we have about what the reporter did in his presentation. Now, in the introduction, we think that he did a pretty good job. Then in the theoretical explanation, he had a pretty big lack of knowledge, and then in the setup, he was pretty good. The experiments were pretty much poorly done. The comparison was again poorly done because of the lack of knowledge that happened to exist in the theoretical part, and then we have a pretty good conclusion. Now, let's see the strong and weak points in the theoretical part. First of all, we have some strong points, the presence of hypotheses and objectives, and the chemical reactions were pretty good presented. But then we have some weak points too. He didn't make any quantitative predictions, he didn't explain the predictions he had. Again, he had very poor understanding of the phenomenon and no very satisfying answer to the questions I asked him, the clarifying questions. Also, he hasn't defined any terms, and more visual aids could have helped a lot in his presentation. Also, he uses a lot of formulas, but none of them were explained and their role wasn't clearly presented. And also, he didn't the role of each compound, because all of them are very, very important in the reaction and in the production of hydrogen. So that's why I gave him a 2 out of 5 points in our point of view. Then, in the experimental part, also we have strong points and weak points. As happened in the theoretical part, we have the variation of the concentrations and the variation of parameters like temperature. Also, we have some weak points. Visual aids were not explained, and he had pretty unclear graphs and explained them very briefly. Also, no clear connection between the parts. Slide 24 wasn't the best, hadn't the best reactions, because water and aluminium don't react by themselves, because aluminium forms a layer of oxide on it. So any reaction will never happen between them, but we will discuss about that in the discussion part. Also, didn't control many of the parameters that could influence the reaction. No quantitative data was mentioned. Also, no errors mentioned, because they can happen in this reaction. Also, no clear conclusions. The reactions were not explained on what are their roles and so on. Some of the reactions were again not correct, like on slide 24 or in other parts of the experimental part and even theoretical parts. Also, no comparison between the experiments he did and not analyzed the linear slope. And that's the reason why I gave him here a 1 out of 5. Now, I would like to move to the discussion topic with the reporter.
Okay, thank you very much for this opposition, and we're going to move on to the discussion in which the reporter can respond to your critical remarks.
Okay. So, my first question. Aluminium always forms a layer of oxide. I talked about that in the weak points of the experimental part. Can you please tell me, does aluminium react with water by itself, or it needs something to destroy that layer of oxide?
I write that there is sodium chloride, and that is that there are chloride ions in solution that destroy the oxide film, and aluminum reacts with water without its oxide film.
Okay.
Without its layer of oxide.
Okay, thank you, but I'm pretty sure that the layer of oxide is mostly destroyed by an hydro acid, like the hypochloric acid acid or hyposulfuric acid and so on.
Can you explain where in the solution appears hypochlorite ions? There is only
In the moment of the ionization.
and copper ions and
Okay, may I respond to your question? In the moment of the ionization, all these compounds split, and thinking that water splits in hydrogen and hydroxide molecules, they combine and form the hypochlorite acid. Now, let's move on. Did you measure the volume of hydrogen you obtained experimentally? And if yes, you did, how did you measure it?
I measured. Can I my presentation to see you the experimental setup?
I don't think so, because I am already presenting mine and I don't want to eat too much time. Now, okay, I think that, can you explain how you did it? Hello, can you hear me?
There was a hydrogen collecting tank, and when hydrogen will be in this tank,
Okay, a hydrogen collector.
we need and then it pushes water into this container, and I measured a mass of water. Then I measured a volume of this water, and so I measured the volume of the hydrogen.
Okay, thank you. Now, can we talk a bit about the ionization?
To measure the amount of
Can we please talk
and the amount of water.
It's okay. It's okay. I understood how it works. Okay. Now, can we talk a bit about the ionization process? The ionization of the elements, because each salt, when you combine it with water and you form an aqueous solution, ionizes and forms a lot of ions that will react with one another and with aluminium for producing the hydrogen quantity. How did the ionization process work in your case, or in your point of view?
All strong salts are dissociating in the water solution, and the strong salts are copper sulfate, sodium chloride, sodium hydrosulfate, and ferric chloride. They dissociate by metal ions, some salts with hydrogen ions, and with chloride or sulfate ions. But this is not necessary, because I can write the equation, the reaction equation, but in general.
Okay, thank you. I understood what you wanted to say, because we have only 1 minute left and I have more questions. What is the role of the metals that formed after the ionization process, like copper and sodium, for example?
Can you repeat your question, please?
What is the role of the metals formed in the ionization process, like copper and sodium, for example, in the reaction gave by the problem?
Copper sulfate reacts with aluminum, and there we get copper and aluminum sulfate. Natrium or sodium is more active than aluminum, and then there no reaction between sodium chloride and aluminum.
All right, and now one more question. What is the name of the solid compound found in the container where you performed the experiment? Because always a solid thing formed.
Short answer, please.
What do you mean about, what do you mean by your question? I don't understand.
Okay, sorry, this is not a short answer. So I would like to thank the reporter and the opponent for the discussion. And there is no further time for the discussion. Let's move on to the questions from the reviewer, please.
Of course. First, can you hear me?
Yes, we can hear you properly.
Okay, to the reporter, how did you fit the lines for your slope calculation on, I believe it was 11th slide? Hello?
I approximate it are equal, because the step of these scales are equal.
but never mind. Anyway, you said you had repetitions, but what about the error bars on your graphs? What did you do with that?
So the errors were very small, and they will make graph dirty.
Oh, okay. And you said that you controlled the temperature, but how was it kept stable for the whole duration of your experiment?
Please, can you repeat your question?
How did you keep your temperature stable for the whole duration of your experiment? Did you?
Using cold water and hot water, I tried to keep temperature nearly 25 grados plus or minus 1 gradus Celsius.
Okay, the answer is clear. Thank you so much. We have preparation time for the reviewer, please.
Overall, the analysis of the problem and the experiment itself were okay, but theoretical introduction, his hypothesis, analysis of data, and conclusion weren't as good and have a lot of room for improvement. The opponent, on the other hand, quality of reactiveness. He asked about the effect of the temperature on reaction, and he noticed possible errors in controlling the temperature. He noticed the lack of errors, slope analysis, and lack of quantity results. He noticed the lack of theory and the incorrect formulas, but he didn't notice that hypotheses were not proved or denied. But one important error is that he missed the lack of repetitions and error bars, and he didn't question if the temperature was stable. He didn't ask about measuring the temperature and didn't ask about the duration of the experiment too. As for the discussion, firstly they discussed the aluminum forming a layer of oxide and therefore lesser possibility of immediate reaction. They thought that aluminum needs the oxide layer destroyed for the reaction to occur, and the reporter didn't derive any conclusion or improvement from that topic. Hydrogen volume and experimental measurement, I talked about this earlier, and the opponent presented a very valid question, get no conclusion from the reporter. They also talked about the copper role in that experiment, and the opponent presented a valid question, but there was again no conclusion. And opponent did a very good job questioning, but could get very few relevant answers, showing that the opponent showed great knowledge about the phenomenon. And with that, I would like to end this, and thank you for your attention.
Thank you very much. Thank you. We now move on to concluding remarks from the opponent, please.
Okay, so first of all, I want to thank you guys for this match, and now I want to have some things to say. The reporter didn't understand at all the reactions because there were a lot of wrong chemical reactions. Also, he didn't mention that the hydrochloric and sulfuric acids are the ones that destroy the outer layer of the aluminium, and that the copper is the stabilizer of the reaction. Also, the quantitative data was poorly explained, and he didn't mention why when you demonstrations of.
Thank you for attention.
Okay, thank you very much indeed. We now move on to questions from the jury. So, jurors, please ask your questions anytime you like. Questions?
I have a question. Can the reporter please again show the slide where he has the law? I don't remember the name. It was like one of the first theoretical slides, and explain what the role of that law is in this experiment.
You mean this slide?
I am still loading the screen, but probably yes. I can't see the slides yet.
Van Hoff law. There was the dependence, the rate of the reaction on temperature. You mean this?
Yes, but for what did you use this in your presentation? Why do you need this?
I used this law in the 20th slide, and I get the temperature coefficient of this reaction. May I send to the presentation after your questions in the chat?
Yeah, it's fine. Thank you.
Okay, further questions, please.
I would have a question to the opponent.
Further questions from the jury. Okay, apparently there are no other further questions, so I would like to thank the jurors for the questions and the teams for the answers. Let's move on to the next phase, which is grading. So I ask all jurors to please decide on the grades, send them to me in a direct message, and then I will collect all of them together in one place, and then we will announce and discuss the grades. Mark, so the procedure is as follows. You decide on your grades. You have 3 numbers, and you send these 3 numbers to me in a direct message.
Okay.
And in the meantime, as we saw in the beginning of the fight, our juror Alexandros Kiziridis was missing. Then you came back, and I see that you were watching the whole stage. So yeah, in case you're ready to provide your grades, we will very happily collect them. You are in the jury. But in case you still continue to have technical issues, then it's okay if you skip. Once again, we see you in the group, and you are a juror on this group according to the schedule.
Hello there, I'm here during the whole match. I've heard everything.
Very good, so we need your grades.
Yeah, I'm sending them right now. Just a moment.
She tried to vary incubation time, and she talked about theoretically about the door-handle bacteria. Also had statistical data and a graphical side. Now, for the areas of improvement, I'm going to be talking about, as I already said, there is a gram negativity and gram positivity side, which shortly said just explains the wall buildup of the bacteria and how the disinfectant actually affects the bacteria. And this is actually a really big side of the experiment. She didn't talk about the specific side of the problem, which I already said was the deactivation side. She didn't tell us the specific disinfectants that she used, and explained the gender differences with the logic that females wash hands differently and used that as a valid argument, which I disagree with fully, and didn't talk about the type of agar she used, which will make a difference because some agars are able.
Okay, now all jurors are ready. I will first read the grades from each juror, then we will comment on them, and I will also type them in the text channel. So the grades are as follows. To the reporter, Ilya, 18, Milan, 24, Raman, 16, Dorian, 13, Alexandros, 17, and Mark, 12. To the opponent, Ilya, 15, Milan, 15, Raman, 16, Dorian, 15, Alexandros, 14, and Mark, 14. To the reviewer, Ilya, 8,
Not, I mean, as long as it's consistent in this fight, it shouldn't be a problem, and maybe I will just be the lowest for the rest of the fight. But I had a few issues, especially with the theoretical part of the report. Formulas that were there but not really explained, graphs that were hard to understand, and then conclusion which I couldn't really connect to the experiment. So just a few minor issues which didn't really convince me in the end. I had partial grades -2, +1, -1, -1, so a 12 in the end.
Thank you very much. Milan, your grade was the highest one for the report, 24.
Yes, actually, I had pretty high marks for the three teams because I thought that all three teams were well prepared on that subject. I honestly enjoyed the performance of the three teams. The reporter showed a nice experimental setup. They had good results. The only thing I was missing were some novel ideas and depth of research. But the three teams' performances led to a very enjoyable fight, for which I'm thankful. Guys, good job on that. Thank you.
Okay, thank you. With the opposition, the grades were very close. Basically, all jurors were giving only one of three possible grades, 14, 15, and 16, which are all very high grades. Would any one of the jurors like to comment on any of your grades, please? Because they're all very similar. Well, I will comment myself. I had an impression that the report itself was very good on its own because it had results and it had experimental analysis and it had theoretical analysis, and there were a lot of scientific points to discuss and address. And the opponent addressed all of these points, and the opponent was attentive to detail and has criticized a lot of points and has discussed a lot of issues with the reporter, and therefore I think the discussion was active, and the opponent was quite successful in their job of discussing the report, the contents, the scientific essence of the report with the reporter and giving their criticism and analysis of the report. I think you were quite good in that. For my grade was 15. And with the opposition, with the review as well, I'm sorry, the grades are also very similar. Still, we had one lowest grade of 7 from Alexandros. Would you comment on your 7, please?
Yes, of course. Well, this is the last time fight tournament, and I'm just waiting to be impressed in order to have high scores. I just think he did the reviewer did his job quite well, but I think 7 is what he should really deserve for this fight.
Okay, and Raman, your grade was one of the 2 highest grades for the review. Would you say a few words about the review, please?
Well, I was rather enjoyed by the opposition and the review, so I was rather loyal for them, and I really enjoyed what both of them spoke. Sorry. So I was rather loyal and gave very good grades for both of them.
Okay, we're out of time, so I would like to thank all teams who had a very interesting stage. We had an excellent experimental and theoretical work, and we had a lot of discussion about this work from the opponent and reviewer. I would like to congratulate all teams on this very good start of our semifinal fight in the Group C. Let's make a break of 10 minutes, and then please be back on time, and we start with stage 2. Thank you. Okay, we shall be starting soon. I will check briefly that all jury members are here and all team members are here as well. Team Romania, please confirm.
Yes, we are here.
Very good. I think you can already start your preparation in a few seconds from now.
Okay.
Team Croatia.
We are here.
Team Russia, uranium-239.
We are here.
Okay, very good. So Team Romania is our second reporter in the stage 2. And please start your preparation and please start your report as soon as you can.
Okay, so can everyone hear me properly and see my screen?
Yeah, we can.
Okay, so I have 10 more seconds, but I think I can start.
Yes, please start.
Hello everyone, my name is Ioana Popa and today I'm going to be the reporter from Team Romania on problem number 14, chemical oscillators. Examples of oscillating chemical reactions are the Briggs-Rocher reaction or the Belousov-Zhabotinsky reaction, which result in periodic color changes. While some of such reactions are difficult to reproduce, there are multiple ways to produce a simpler and more reliable chemical oscillator. Propose a problem about an interesting and simple chemical oscillator. In my presentation, I'll start with a short theoretical part where I'll talk about what is a chemical oscillator. I'll give some examples of both complex and simple chemical oscillators, and then I'll give the proposed problem. In the experimental part, I'll present two experiments, the blue bottle and the traffic light. And in the end, I'll talk about possible errors and I'll draw some conclusions. So let's start with the theoretical part. Chemical oscillators are chemical reactions which exhibit periodic changes, like color changes, periodic gas emissions, or foaming up. In the picture on the right, the color change from the Belousov-Zhabotinsky reaction can be observed. These reactions are important because they show that chemical reactions do not have to be dominated by equilibrium thermodynamic behavior. Just take a look at this computer simulation of the Belousov-Zhabotinsky reaction. It's in a continuous movement. The most common examples of chemical oscillators are the Belousov-Zhabotinsky reaction and the Briggs-Rocher reaction. They both exhibit periodic color changes, as presented in these videos. They are complex reactions, which are quite difficult to understand. That's why I chose to study two less complex chemical oscillators, which are the blue bottle experiment and the traffic light experiment. In the first one, there is a color change from blue to colorless, and in the second one, the color changes from yellow to red to green. These are very similar experiments because they are both based on a redox reaction. They both use glucose dissolved in a basic medium, and the color change is triggered by shaking the solution. In my experiments, I want to study the cycle time and its variation when changing the reactant's concentration and the temperature in both the traffic light experiment and the blue bottle experiment. By cycle time, I mean the elapsed time from the moment I started shaking the solution to the moment when it gets back to its original state. Don't forget this terminology because I will use it often in the next part of my presentation. My hypotheses are the following. The cycle time increases with the number of times you shake the solution. The cycle time I'm sorry? The cycle time decreases when increasing. Can you pause the time, please, for a second? So what's happening?
We couldn't hear you the last slide, but now we can. So everything.
Please continue. Please continue.
The cycle time decreases when increasing the concentration of the reducing solution. The cycle time decreases when increasing the temperature of the water used. And the reaction dies after a limited number of cycles because the glucose is consumed. So let's start the experimental part. I'll start with the blue bottle experiment, where I use methylene blue, glucose, sodium hydroxide, which is a catalyst, and distilled water. The methylene blue has two forms, the reduced form, which is colorless, and the oxidized form, which is blue. The methylene blue goes from the colorless form to the blue form when combining with oxygen, and the blue form returns to the colorless form after mixing with glucose and sodium hydroxide. The color change observed is a result of the reversible oxidation-reduction reaction of the indicator present in the reaction. The figure shows that there are three main groups of reactions in the blue bottle experiment. Oxygen reduction reactions, oxidation and reduction of redox indicators, which is methylene blue in our case, and the oxidation of the reducing agents. In a round bottom flask, I made a solution using 5 grams of sodium hydroxide, 5 grams of glucose, and 125 milliliters of distilled water. Then, I added 1 milliliter of methylene blue in the flask, as shown in the video on the right. This is what happens during one cycle. The solution changes its color twice during a cycle. It first goes from colorless to blue while shaking, and then it becomes colorless again when it is let to rest. I varied the concentration of the reducing solution and plotted this in a graph. It is very important to mention that for the measurements plotted in this graph, I used a magnetic stirrer in order to agitate the bottle constantly and uniformly. The blue line represents the standard solution with the ingredients presented in the procedure. The red line referred to a solution with a higher concentration of the reducing solution, while the yellow line represents a solution with a lower concentration of the reducing solution. Because the difference between the blue and yellow lines is far bigger than the distance between the blue and red lines, I put on this slide two graphs, the first one being a zoom-in picture of the second one. Also, we can say that the cycle time increase is not linear with the concentration decrease. The trend lines are horizontal, which means that hypothesis 1 is false. The cycle time is approximately constant. From the order of the three lines on the graph, we can tell that the second hypothesis cycle time decreases when increasing the concentration of the reducing solution. Let's move on to the traffic light experiment, in which I used the same ingredients from the previous experiment, except from the redox indicator. In this reaction, I used indigo carmine, which can exist in three forms: an oxidized form, which is green, a reduced form, which is yellow, and an intermediate form, which is red. The indigo carmine turns from yellow to red to green when mixing with oxygen. The green form turns back to yellow in the reaction with glucose and sodium hydroxide. The chemical reactions which happen are similar to the ones presented in the blue bottle experiment. The glucose is reduced, so gluconolactone is formed. The redox indicator, which is the indigo carmine this time, is oxidized and reduced. The red form is just an intermediate form, which is quite unstable. The recipe I used in the experiment is the following. In a beaker, I dissolved 2 grams of glucose in 50 milliliters of hot water. Then I added 10 milliliters of sodium hydroxide solution. In another flask, I put 50 milliliters of hot water and a little bit of indigo carmine. In the end, I added the alkali glucose solution in the flask as shown in the video on the right. Here you can see the color change from yellow to red to green and back. It can be observed that the color change from green to yellow occurs slower. Here, I made a comparison between the two traffic light solutions. On the left, there is a solution prepared just before the video was taken, and on the right, there is a solution prepared one day before. It can be seen that the fresh solution changes its colors more faster than the other one, because there is a limited number of cycles in which the solution changes its colors. The second solution lost some of its properties because it had already been shaken more times than the first one, which confirms the fourth hypothesis. I observed that the number of times the solution can be shaken until it dies, meaning the fact that it loses its oscillation capability, is around 6 times. Adding more glucose makes the solution become reversible again, which means that the pipe through. The reaction dies when the glucose is consumed. This is because the oxidation of glucose into the gluconic acid is an irreversible reaction. In these two graphs, I represented the cycle time depending on the water temperature. In these measurements, I used a constant temperature magnetic stirrer. The quantities used for preparing the solution were the same. The only parameter that varied was the water temperature. It corresponds to 100 degrees Celsius, the red line to 75 degrees Celsius, the red line to 75 degrees Celsius, the yellow line to 50 degrees Celsius, and the green line to 20 degrees Celsius. From the fact that the trend lines are almost horizontal, we can tell again that the first